So section 6.1 talks about exponential functions. You can see the definition of exponential functions up here. The important part about an exponential function is that it's in this form. F of x, remember it could be y equals b to the x power, but what makes an exponential function is that the x is the exponent. That's the important part. The x is the exponent. So, example 1, graph y equals 3 to the x power, state the domain and range. So we're just going to explore what an exponential function looks like and why it looks like it does. With a t-chart, so I will do a t-chart with your standard numbers 2, 1, 0, 1, and 2. So when we plug those numbers in for x, what do we get for y? So when we replace the x with a 2, we would have 3 to the second power, and that equals 9. 3 to the first power equals 3. And what is 3 to the 0th power? 3 to the 0 power, if you recall from Algebra 2, equals 1. And then these are supposed to be negatives. 3 to the negative 1 power. What's a negative exponent mean? Negative exponents are the reciprocal exponents. So 3 to the negative 1 power actually means 1 over 3 to the positive 1 power. And that equals 1/3. Come on, pen. And then, let me roll up a little bit here, give myself some more room. 3 to the negative 2 power, well, that would equal 1 over 3 to the positive 2 power, which equals 1/9. And if I were to graph those in this coordinate plane, I would have 2, 9, so that's right here. Whoops, that's actually right here. Erase that. So 2, 9, 1, 3, 0, 1, negative 1, 1/3. So negative 1, 1/3. And I think I missed my 0, 1 up there. Let's try that again. So it's 0, 1, and then negative 1, 1/3, and then negative 2, 1/9. So this is what the graph looks like. It's very steep on this side of the graph. On the left side of this graph, it is actually very, very, very flat. It makes a quick turn here, kind of flattens out. So it looks roughly like this. So you can clearly see what's going on the right side of the graph, but excuse me, what's going on the left side of the graph. So I've actually graphed that on a graphing calculator, and this is a more accurate representation of what's going on. So again, you can see how steep it is on the right side of the graph. But what's going on the left side of the graph as it gets closer to the x-axis? When does it actually touch the x-axis? Looks like it's touching at negative 5, but when I zoom in on negative 5, you can actually see it is a little bit higher than negative 5. So if I keep going to the left, it is getting closer and closer and closer to the x-axis, and it looks like maybe it's touched in at around negative 7, but when I zoom in on negative 7, you can see that it's actually not touching at negative 7. It's a little bit above negative 7, but it continues to get closer and closer and closer as I go to the left. So, when does it actually touch the x-axis? The answer is it never touches the x-axis. The basic graph never touches the x-axis because there is no number that I can plug in for that x in order to get y equal to 0. Because that's the only way for it to touch the x-axis is the y has to be 0. I can't use a positive number clearly. I can't use 0 because if I put 0 power, it's going to equal 1. So we figured that out right there. And I can't even use negatives because when I use negative numbers, I got very, very small fractions. I'm supposed to be 1/9 there. So it never touches the x-axis, and we call that an asymptote. So the definition of an asymptote is a line that a graph approaches but never reaches. never reaches. So in this case, the asymptote is the x-axis. Now, what we're going to do is do a lot of shifting, though. So hopefully you've got that written down because I'm about ready to erase it. And let's do another graph that's related to the y equals 3 to the x power. Let's do y equals 3 to the x plus 2 power. So if you recall from Algebra 2, the graphs that have nothing attached to the x, if it's just kind of attached onto the end but is not grouped with the x, this is your vertical shift. And we're going to vertical shift this 2 units up. So every one of those red points that I put in the graph, I'm going to take every one of those points and move it up 2 places. So move this point up 2, move this point up 2, this point at the y-axis goes up 2, and the rest of them go up 2 points. So y equals 3 to the x plus 2 power looks about like this. It's still very steep, still has that same shape. It comes down like this. Now, not only does the points of the graph shift up 2, but the asymptote also shifts up 2. So this x-axis down here, where it flattens out, is also going to be shifted up 2. To show that we have a asymptote and there is a place where it will never reach, we use a dotted line and we try to level it out right there and not actually touching that dotted line. So roughly like that. Okay, let's talk about domains. So on the red graph, what's the domain? Well, the domain is really easy. The domain is all real numbers. The range is a little bit different. The range, remember, describes the y values, and on the red graph, the range is that the y values are always going to be greater than 0. It's not equal to 0 because if it was equal to 0, it would touch the x-axis, but it actually never touches the x-axis, so it has to be greater than 0. So on the blue graph, what's the domain and the range? Well, the domain is still all real numbers. All real numbers, hopefully you can read the writing. But the range, since the asymptote got shifted up 2 units, the range is y is greater than 2. Okay, we can also do this with a horizontal shift. So let's say the graph is y equals 3 to the x power minus 1. So going back to the red graph, if we were to shift that 1 unit, does it go left or right? Remember, horizontal shifts, hang on, I got to back up here. I wrote that down incorrect. I should put the -1 in the exponent. I erased it by accident. So it's x minus 1. There we go. That's what it should look like. It's going to be a shift 1 unit to the right, because remember, horizontal shifts seen backwards. Negative numbers go to the right, positive numbers go to the left. So I'm going to take, again, from the red graph, I'm going to shift all these points over to the right 1 unit. So the green graph should look about like this. Looks very similar to the red graph. And since I shifted left to right, if you move a horizontal asymptote left to right, it actually doesn't move. So it levels out in the same place as the parent function, the red one. So the granddaddy of them all is going to be a problem like this. And this is going to be what your full process would look like as you're doing an assignment. So you're supposed to graph y equals -1/2 times 5 to the x minus 2 power. So we start with that by doing a t-chart, but we're only going to do a t-chart with everything that does not include the shift. So it's y equals -1/2 times 5 to the x power. We're going to ignore the -2 part because the -2 is the shift. We'll do a quick t-chart with just -1/2 times 5 to the x power. That should be to the x power, not at 5x. So 2, 1, 0, -1, -2. We'll have -1/2 times 5 squared, which equals -12.5. We'll have -1/2 times 5 to the first power, which equals -2.5. We'll have -1/2 times 5 to the 0 power, which equals -1/2 or -0.5. And then when you have -1/2 times 5 to the -1 power, remember that's the reciprocal asymptote, so that's the same as -1/2 times 1/5, which is -1/10. And then -1/2 times 5 to the -2 power would be -1/2 times and 1 over 5 squared, which would be -1/50. So this is what I'm graphing. I'm graphing 2, -12.5, which goes off my graph just a little bit, roughly there. 1, -2.5. 0, -1/2. -1, -1/10. -2, -1/50. So we're getting pretty small there. So you can see this one actually goes downward, and you may have predicted it could go downward because of that negative sign that led off the equation right back here. You can see that. The negative sign kind of indicated it was going to go downward this time. It was a reflection across the x-axis, to be more technical about it. And then this was just the parent function, because remember the graph was originally up here with a shift of -2. And which direction does that go? Since it's grouped with the x, that's actually a shift of 2 to the right. So all those points, I'm going to move 2 to the right. And let's see, this point goes 2 to the right. And then this one's 2 to the right. So it looks about like this. Makes that quick turn and levels out again. So, what's the domain of the green graph? Remember, it's all real numbers. What's the range of the green graph? Well, this time, since it's below the x-axis, the range is y is less than 0. And since the asymptote, which is the x-axis, shifted left to right, it doesn't move at all, really, because lines go forever.